everyone. Myself, Dr. Ashok Babu, working as Professor and Head, EC Department. So in this video, I am going to discuss about the some important definitions of Module 1, that is electrostatics. First one, define Coulomb's law. The Coulomb's law can be defined as the force between two very small objects separated in a vacuum or free space by a distance, so which is large compared to their size. So is proportional to the charge on each and it is inversely proportional to the square of the distance between them. So here we can write it as F is directly proportional to this Q1 Q2 by d square. So or it is F is equal to some constant K into Q1 Q2 by d square. So it is a definition of a Coulomb's law. So what is the orthogonal system? So it is one in which the coordinates are mutually perpendicular to each other. So what is the point charge? The point charge is one whose maximum dimension is very small in comparison with any other length. This is known as a point charge. So point charge means at that particular point only we have the charge. So let us assume this is a point. So let us assume it is having the charge Q. So at this particular point only we have the charge. So what is dot product? So it is defined geometrically as a product of the magnitudes of two vectors and the cosine of the angle between them is known as a dot product. So what is the effect of permittivity on the force between the two charges? So here we have the force. We have the formula force F is equal to it is Q1 Q2 by 4 pi epsilon naught d square. Therefore, F is inversely proportional to epsilon. F is inversely proportional to epsilon. So here, if we increase the epsilon naught value, automatically the force decreases. So increase in permittivity of medium tends to decrease the force between two charges, and decrease in permittivity of the medium tends to increase the force between two charges. So state Gauss law. So it states that the total electric flux through any closed surface is equal to the total charge enclosed with that surface. So it is mathematically, you can represent it as psi is equal to Q enclosed. So here psi is the flux, Q is the charge in the closed surface. Next, state applications of Gauss law in electrostatics. So Gauss law is applied to find the electric field intensity. Mainly Gauss law is used to find the electric field intensity from a closed surface or to a closed surface. The examples of electric field can be determined for a shell or two concentric shell or cylinders. So it is another example of a finding electrostatics in a closed surface. So what is electric flux line? So it is an imaginary path or line drawn in such a way that its direction at any point is the direction of the electric field at that particular point, which is known as a electric flux line. So define divergence theorem. So here the integral of the normal component of any vector field over a closed surface is equal to the integral of the divergence of this vector field throughout the volume enclosed by the closed surface. So I repeat the definition. The integral of the normal component of any vector field over a closed surface is equal to the integral of the divergence of this vector field throughout the volume enclosed by the closed surface. So what is the significant physical difference between Poisson's and Laplace equations? So when the region of interest contains the charges, then we can use the Poisson's equation, and it can be used to find the potential. So when the region is free from the charges, then we can use the Laplace equation, which is used to find the potential. So if there is some charge, we can apply the Poisson's equation. If there is no charge, we can apply the Laplace equation to find the potential. So there is a difference between Laplace and Poisson's equation. So define current density. So the current density at a given point is the current through a unit normal area at that particular point. So define current. So here the current, it can be measured in amperes. The current through a given area is the electric charge passing through the area per unit time. Next, define linear, isotropic and homogeneous dielectric mediums. So these are the three definitions of a dielectric material. So a material is said to be linear. If electric flux density varies linearly. If electric flux density D varies linearly with electric field E. So if D is proportional to E. Then we can say that the medium is a linear medium. Materials for which the permittivity does not vary in the region being considered and is therefore the same at all the points are said to be homogeneous. So if epsilon is constant throughout the medium, throughout the area, then we can say that that medium is a homogeneous medium. Then materials for which the electric field intensity and electric field strength are in the same direction, electric field intensity and electric flux density, if both D and E are in the same direction, then we can say that the medium is a isotropic medium. So explain electromagnetics. Electromagnetics is a branch of physics or electrical engineering in which the electric and magnetic phenomena are studied, is known as a electromagnetics. So what is a field? A field is a function that specifies a particular quantity everywhere in a region. So let us assume it is a region. So it is this particular point. Let us assume a function. So a field is a function that specifies a particular quantity. So it specifies a particular quantity. It may be a voltage or it may be a current. It may be voltage or it may be current. It specifies a particular quantity everywhere in the region. Throughout the region, it should specify the voltage or current. That is known as a field. Define a scalar and vector field. A scalar field is the quantity which has only magnitude. A vector field is a quantity which is having both a magnitude and direction. Then define unit vector. So by the definition of unit vector having unit magnitude and which is parallel to the coordinate axis and the point of the direction of increasing coordinate values. So the point and the point in the direction of increasing the coordinate values is known as a unit vector. So define potential difference. Potential difference is defined as the work done in moving a unit positive charge from one point to another point, in an electric field is known as a potential difference. Define conservative property of electric field. So the work done in moving a point charge around a closed path in an electric field is zero. Such a field is said to be conservative field. Let us assume like this, closed path. So because of a closed path, the work done required in moving a point charge from one point to other point is always zero. Such a field is known as a conservative field. So define permittivity. So here it can be defined as it is a measure of refractive, it is a measure of the relative effectiveness, it is a measure of the relative effectiveness of the substance such an electrical insulator, or the extent of reduction of electric fields and consequently reduced strength of electrostatic interactions in a medium, which is known as the permittivity. So I repeat the definition. So it is a measure of the relative effectiveness of the substance as an electric insulator, or the extent of the reduction of electric fields and consequently reduced strength of electrostatic interactions in a medium is known as a permittivity. So define Stokes theorem. It states that the circulation of vector field around a closed path is equal to the surface integral of the curl of a vector of the open surface. So here if you apply Stokes theorem to a line integral will convert into a surface integral. This is one of the advantages of a Stokes theorem. So what is the relaxation time? So it is the time it takes a charge placed in the interior of the material to drop to 36.8% of its initial value is known as a relaxation time. Define electric flux line. So electric flux line is an imaginary path or a line drawn in such a way that its direction at any point is the direction of the electric field at that particular point is known as the electric flux line. So define capacitance. So here the capacitance of this two conductor system as the ratio of the magnitude of the total charge on either conductor to the magnitude of the potential difference between the two conductors. Simply you can define capacitance C is equal to the ratio of charge to potential. C is equal to Q by V. So what meaning would you give to a capacitance of a single conductor? A single conductor also possesses a capacitance value. So it is a capacitor whose one plate is at infinity, whose one plate is at infinity, which is known as a capacitance of a single conductor. So what is the distance vector? The distance vector is the displacement from one point to another point is known as a distance vector. So what is the electrostatic force? So here the force between any two particles due to existing charges is known as electrostatic force, or repulsive, which is repulsive for like and which is attractive for the unlike charges. If it is plus Q, it is a repulsive force. If it is plus Q and minus Q, there is a attractive force between the two charges. And define electric field intensity. So it is a force, electric field intensity E. It is denoted as E. E is equal to force per unit charge. So electric field intensity can be defined as it is a force per unit charge is the electric field intensity. Define electric potential. So it is the amount of work needed. It is the amount of work needed to move a unit charge from a reference point to a specific point against in electric field, or in an electric field, the work done required to move a point charge from one point to the reference point to the specific point is known as the electric potential. Define equipotential surface. Equipotential surface as a surface is composed of all those points having the same value of potential. So if the potential is same at all the points, then we can call it as a equipotential surface. So define conservative electric field. So any electric field that satisfies the closed line integral of the field, so which is 0, is said to be a conservative electric field. It means in a closed path, the electric field intensity, or if you find the integration, if you find the differentiation, whatever it may be, then if it is 0, the total electric field is 0 in the closed loop, then we can call the electric field is a conservative electric field. So what is the physical significance of divergence of electric flux density? So the divergence of vector flux density is the electric flux per unit volume leaving a small volume. So this is equal to the volume charge density, which is equal to volume charge density. Next, what is the dielectric strength? So here it is the maximum electric field that a dielectric can tolerate or withstand without breakdown of the electric field, which is known as the dielectric strength. So define electric flux density. So one line of electric flux emanates from plus 1 coulombs and terminates at the minus 1 coulombs. Therefore, the electric flux is measured in coulombs. So hence the vector field D is called the electric flux density and is measured in coulombs per square meter. Then what is the electric dipole? So an electric dipole is formed when two point charges of equal magnitude but opposite sign are separated by a small distance. Then that is known as a electric dipole. So how is electric energy stored in a capacitor? So in a capacitor, the work done in charging a capacitor, is stored in the form of electric energy in a capacitor. So define metal and insulator. A metal, let us assume a material with a high conductivity, which is referred as a metal, and let us assume the same material which is with low conductivity is referred as a insulator. So define relative permittivity. So it is the ratio of the permittivity of the dielectric to the free space is known as relative permittivity. State point form of Ohm's law. So point form of Ohm's law states that the field strength within a conductor, is proportional to the current density, which is known as the point form of Ohm's law. Then define point charge. A point charge is an idealized model of a particle which has an electric charge. So a point charge is an electric charge at a mathematical point with no dimensions. Simply at that particular point only we have the charge. This is known as a point charge. So here apart from the point charge, here we have different charges. Line charge is there, surface charge is there, volume charge is there. So these three charges are known as the continuous charges. So line charge means throughout the line we have the charge, throughout the surface we have the charge, throughout the volume we have the charges. So it is the difference between point charge and continuous charges. So point charge means at that particular point only we have the charge, whereas continuous charge means throughout the line or throughout the surface or throughout the volume we have the charge distribution. So this is the difference between a point charge and a continuous charges. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.